Welcome to Design and Analysis of Algorithms class. Today we are going to dealing with multi-threading merge sort under multi-threading algorithms under unit 4, right? So in the last class we have seen what is meant by multi-threading and what are all the basics of multi-threading, and also you have seen multi-threading matrix multiplication also, and this is another application under multi-threading which is multi-threading merge sort, right? So in today's class I am going to cover what is meant by multi-threading merge sort followed by algorithm. Even the previous version normal merge sort algorithm and the multi-threaded merge sort algorithm also, and also we will see the analysis part. And coming to the objective, and with today's lecture the students are able to understand the concept of multi-threaded merge sort. Now coming to the outcome, with today's lecture, after learning this lecture the students are able to acquire the knowledge on multi-threaded merge sort. So now this is a serial version or the previous version which you have learnt as part of divide and conquer, right? So under divide and conquer chapter you have already learnt the merge sort, right? So this is the algorithm for merge sort as you have already seen. A, here A stands for the array or list of elements and P is the lower index or the starting index and R is the high index or the last element index, whereas A is list, right? So now if P is less than R, what I am supposed to do, I have to find the mid position. So that mid position I am representing with Q over here. So Q is equal to P plus R by 2. So now after that I have to apply this merge sort algorithm on the first list. That first list is nothing but first half list starting from P to Q, whereas P to Q is list 1 and Q plus 1 to R is list 2, right? So I need to apply merge sort on list 1 as well as I need to apply this merge sort on list 2. So here merge sort of A comma P comma Q, whereas again I need to apply the merge sort on the second list, whereas the second list starting from Q plus 1 to R. Now after applying merge sort on the two lists, the other thing is to combine these two lists, right? Combine those two lists and I need to apply sorting again. So that for combining I am using merge algorithm. So merge A comma P comma Q comma R, right? And you have already seen the merge algorithm as part of your divide and conquer. So this is about your merge sort algorithm, right? Which is a serial version. Now we will see the parallel version. So how to execute parallelly, right? By applying multi-threading. So now this is a parallel version. So here merge sort of in the same manner, here also the three parameters A, P, R. A is the list, P is starting index and R is the ending index. Now if P is less than R, what I am supposed to do? I need to find out the mid index, right? Q is equal to P plus R by 2. Now here I am applying spawn on this, which is merge sort on A comma P comma Q. So this is my thread A, right? Now spawn of merge sort of A comma Q plus 1 comma R, which is another list, right? So this is my thread B, right? Now here sync. So this sync will starts whenever the children are completed, right? So here this spawn are the children, right? So until and unless the completion, so okay, so after completion of these two, the next, okay, the next instruction will be started. What is the next instruction? Merge. The next instruction is merge, right? So here after completion of these two, here I have sync. So after completion of these two, the merge instruction will be executed. So now here how this will be executed? Parallelly. So here in two processors, this is, let us suppose this is P1 and P2, right? So P1 will start thread A and P2 will start thread B, and after that I am going to combine these two by using thread C. Understood? So this is your thread C. So here on two processes parallelly this thread A as well as thread B will be executed, whereas previously on the single processor itself, this is a single processor. So on this single processor itself the list gets divided and this list 1 will be processed and this list 2 will be processed. This is the previous version, whereas at present processor P1 and processor P2. So on P1 thread A, on P2 thread B, and finally this thread C, right? This is a basic difference between the previous one and the next one, right? Algorithm is almost same, and here spawn, sync, right? So this is about your merge sort parallel version or multi-threaded merge sort. Now let's see the analysis part, right? So previously you have already seen the merge sort recurrence relation. What is that recurrence relation? T of n is equal to 2t of n by 2 plus Cn. So why it is 2t of n by 2? Because the list is getting divided into two sublists, sublist 1, sublist 2, and this sublist 1 has to be sorted and this sublist 2 is also has to be sorted, right? So here two separate lists and these two separate lists has to be sorted separately, right? So for that 2t of n by 2, for half list which is t of n by 2, and for the again half list which is the time required for half list is t of n by 2 and the time required for the remaining half list is t of n by 2. That's why t of n by 2 plus t of n by 2 is 2t of n by 2. Whereas Cn is for time requiring for combining these two. For combining these two, how much is the time required? That is Cn. So here this is t of n by 2 and this is t of n by 2 and this is Cn. So together the time required is 2t of n by 2 plus Cn. Now if I am solving it by using either by substitution method or by Master's theorem, I am getting theta of n log n. That is the serial version, right? Now let's see the parallel version. Let's see about parallel version. Now coming to the parallel version merge sort. So t of n is equal to t of n by 2. Why it is not 2t of n by 2? Because here each thread is separately processing on a different processors, right? So here it is P1, P2, two processors, right? On this thread A and on this thread B is executing, right? So parallelly both are executing within the same time. Parallelly both are executing within the same time. So that's why it is t of n by 2. Why it is n by 2? Only half list, right? Here thread A is nothing but half list, thread B is also half list, and parallelly they are executing within the same time. That's why it is t of n by 2, and Cn is for merging. So finally when I am solving this by using substitution method, I am getting theta of n, whereas previously it is theta of n log n. Now it is reduced to theta of n. In today's class we have seen what is the serial version of merge sort, that is with the help of divide and conquer, and also we have seen parallel version by inculcating multi-threading concept into the merge sort algorithm, and also we have seen the algorithm, simple algorithm where I will be having 3 threads. First thread is nothing but dividing your first list, okay, nothing but applying the merge sort on first list, and thread B corresponding to applying the merge sort on second list, whereas the thread C corresponding to combining these two lists, right? And also we have seen the analysis part, which is the previous merge sort which uses divide and conquer strategy, the time complexity is theta of n log n, whereas now it is reduced to theta of n, right? Thank you.